Okay, let's get started. Well, we've only one last thing to do, and it's going to be to do linear differential equations. The only difference is we're going to have an initial or boundary condition, and this piece of information is going to allow us to get the plus C. And I'm going to put you all on mute so we don't get background sounds. Okay, we're good. So half of what we're going to do today, and we've already practiced yesterday, and that is getting the general solution. So this one here is similar to question 11 in your homework. As you look at this question, can you see any problem? Is it ready to be used, or do I have to fix it? Okay, and the problem, of course, is that guy, isn't it? Because the derivative has to be in its own. So I'm going to divide everybody by 2x. And that means I now have p of x, which is 1 over 2x. That's going to cause a slight issue. You might not think so, but it will. And we got that guy. Step 1 done. Now we're trying to find, oops, yes, that guy, e to the integral of px dx. This too isn't very remarkable, but it actually can cause all sorts of hiccups. Right? So here's the problem. I want to find that. Now, if I rewrite it as 1/2 1 over x dx, if I pull out the half, I get that. And I get the answer 1/2 the natural log of x, which can then become x to the half, which can then become that guy. So far, so good. Now, there's a different approach. Suppose I make u equals 2x. Then du equals 2. Well, du by dx equals 2. Crossover gives me that. So what do we have now? Well, we have a 1 over u, a half du, 1/2 1 over u du, 1/2 log u du, 1/2 the natural log of 2x, which becomes the natural log of the square root of 2x. Do you see that there is a discrepancy between the two answers? Yet they are the same integral, yet the results are not the same. Which one do you think is the one we should use? The first or the second? Any opinions on, does this one look cleaner? Or does this one look cleaner? Did you say this one?
Yeah.
Yeah, that's the one I would go with. Now you say, well, what's wrong with it? Actually, nothing's wrong with that. It's really just an idiosyncrasy. If I split it up, you see it's really just made up of a log of square root of 2 plus that? See this thing here? This is just a constant that would end up being added to the plus c, and not a good idea, so we will not do that. So what I've got is e to the natural log of square root of x, and that gets me the square root of x guy. Or I could call it x to the half, I guess. And if you said, well, what happened if I did use that? Nothing at all. You just get a different version of the right answer. Your plus c would be different than the other person's plus c, that's all. Yours would be like a plus c plus the square root of 2, or just a plus c. Okay, so we got step 2 done, so let's get step 3. One over this, the integral of this, that's c. So it's going to be 1 over, I don't know, I think I'll call it x to the half. The integral of, well, 3 and x to the half, so I guess you just get that. Add c. Okay, add 1 to the power. Divide by the new powers, like multiplying by 2/3, so you'll get a 2. I'd probably call this x to the negative a half. Then distribute it, and you get 2x, which is quite nice. And kind of ugly looking guy. I'm really just doing style points. There, I would stop there. Of course, that answer is probably totally okay in the homework as well. Kind of zoom through the last part, but essentially I'm just plugging in things, integrating with the power rule, calling that a negative power so I can distribute it. If you take a half away from 3 halves, you get 2 halves, which is why that's an x. If you give this an x to the negative half, you get this. Bring it downstairs and call it a square root. So that was kind of things that we've done in all sorts of different places, just in this case, it's all happening in one place. We're good? Okay. Well, it's 11, as I say. We don't actually have too much to do today, which is kind of nice. Okay, so...
Are we going to find C?
Say again, Matthew?
Are we going to find C?
Do you know, Matthew, I'm glad somebody in this class is awake, not just me. Yes, we have to find C. So what you're telling me here is that x is 4, y is 23. So I'm going to put in a 23 here. This guy's being 2 times 4, and this guy's going to be c over the square root of 4. So 23 is 8 plus basically c over 2. If you subtract 8 from both sides, you get 15. Yeah, I'd probably call that a half c. If you double everybody, and so you would get that guy. Isn't that really just plug and chug and then solve an equation for c? At least this one is. Can you tell my mind is somewhere else? I'm worrying about my poor wife and trying to get through to that meeting. Yeah. Anyway, focus. Let's focus. Right. So keep an eye on me for whatever other... Oh, God, look at this one. Wow. This is like 13. dv by dt. Take away 2 tv equals 6 t to the 5 e to the t squared, and the boundary condition, initial condition, is that guy. Well, let's see if this fella's in the right form. Derivative on its own, something with a v, something with a t. Yep. So in this case, p of t will be negative 2t.
You have to divide by t.
No, we don't need to divide by t, because we the proper format is to have the derivative on its own, and it is in its own.
Oh, sorry.
I don't need this to be on its own. I just need this to be on its own. So we're looking at that guy. Okay, integrating factor e to the integral of negative 2t dt. That's e to the negative t squared. Ugh. Okay, let's trust the math. It's not going to be y, it's going to be v equals, but that's fine. 1 over I to the t. The integral, oh, I can see what's happening. Okay. I thought it was going to get even uglier until I noticed something. Hopefully you'll see it as well. It's 1 over e to the negative t squared. The integral of e to the negative t squared times this mess. Except something really nice happens. Do you see this guy and this guy, when you multiply them together, is e to the 0, and e to the 0 is 1. And while I'm at it, is there a better way for me to write 1 over e to the negative t squared?
1 over?
What do you mean by 1 over? What would I rewrite?
Oh, I guess, I mean, yeah, you could do 1 over e to the positive, t negative 2. No, yeah.
I think you're trying to say that. Isn't 1 over a negative power the same thing as the positive power on the top?
I mean, that, but I was also wrong, but yeah.
That's where you would have eventually got. I think you were thinking of calling it that, but that
yes
is that.
Yeah.
Right, so eventually, hopefully you would have seen it. This would have gave me that guy. And now we are left with, oh, a simple add 1 to power, divide by the new power, which is and this time I'll try and remember. When t is 0, v is 8. So that's 8 e to the nothing squared, nothing to the 6 plus c. Oh, come on, it can't be that easy. 1 times c is c, c is 8. Right, e to the 0 is 1, nothing to 6 is nothing. Nothing plus c is c, c times 1 is c, c is 8. So our particular solution is this guy, with what, t to the 6 plus 8, or it might be written down like that. I kind of like this one better, but who knows what WebAssign thinks. Are we good with that one? Nothing special happening. Okay, and okay, I am going to give you a question to try for yourself, and that gives me a couple of minutes. I can go and see what's happening with my wife. And this is like question 14. And the linear differential equation is that one. And the boundary condition is that. Okay, so I'll be back in about 3 minutes or so. That's enough time for you. Okay, explain what the problem is. Hi everybody, I am back, and you lot have finished this, right? And went and had a cup of coffee and came back. Right, you were that fast. Okay, let's just get moving and you can catch up if you haven't finished. This t is the issue, so I'm going to divide everyone by t, and so I get that guy. I'll call this 5 over ty, and this just loses one of its powers. In this case, the P of t is that guy, and the Q of t is that guy. So our integrating factor is him, and that's going to get me that fella, which is going to get me 5 natural log of t, and that, you have to realise, is the same thing as a natural log of t to the 5, which means that our integrating factor ends up being a very nice power of t. So 5 over t gets you 5 log, but 5 log's the same thing as a log of t to the power of 5, and e to a log gets me this guy. So we can now get our y. In this case, it's 1 over t to the 5. The integral, oh, almost did a mistake there. T to the 5 times t to the 8. So, oh, t to the 13. Okay, what does that get me? It gets me 1 over t to the 5. If you integrate that, it's add 1 to the power and divide by the new power. I don't know, I think I'm going to make this a little different. If you distribute this, you get 1/14 t to the 9 plus c over t to the 5. Yeah, I kind of like that one. And then I'll use the boundary condition. That's this fella. So if you tell me that when t is 1, y is 0, you get a 0 here. It's 1/14 1 to the 9 plus c over 1 to the 5. It makes c that ugly number. So our final answer is 1/14 t to the 9, take away 1/14 c over t to the 5. Was that the kind of result you got? Because I really kind of shot through that one. I got 1 nod, so I'm calling it good. I mean, the only real difference today is the boundary condition that we use to find C, right? It's the same kind of questions from yesterday.
Why do we still have C in the final answer?
You get a different C than me?
No, like in your answer it says C is still in the
Oh.
answer.
It's not there anyway. But you're right, it was. That was all cut. What we got left? It's got a log in it. Is that interesting? Oh yeah, okay. I think we'll do, we got 2 more. It's like 15, and then the last one we'll do is 17, I think. We have x squared y dashed 2xy natural log of x, and our initial boundary condition is this fella here. You're looking at this guy, the pretty standard kind of look to it. It's also not ready to be used because this guy is not on his own. So basically, if I divide everybody by x squared, it should come out good. Not so happy about that guy, but maybe things will come out nice in the end. We'll see. So P of x is this guy. Q of x is this guy. Let's find the integrating factor. It's equal to the integral of this guy, who is 2 log x. If I want to simplify 2 log x, can't I use one of the laws of logs and convert it into the natural log of x squared? And it's helpful to do that because now we can do the e log cancel process, I guess, and leave ourselves with x squared. So integrating factor is not that bad. Solution then, or general solution at least. Oops, don't know why I put a circle around that. I of x, q of x. That says I of x. Oh, that cancels nicely. Okay, if you've got a really, really good memory, you'll actually know what the integral of log x. If you don't have a good memory, or you're not 100% confident that you want to use what you think the right answer is, we can do this by integration by parts. But let's do the really good memory version first. What is the integral of log x?
X log x minus x.
Agreed. X log x minus x. But I can't find it. I wrote it down. I know it's somewhere, but I can't spend 20 minutes finding it. Let's do it from scratch. This is an integration by parts, but you need 2 things to do an integration by parts. So I call it 1 times the log of x. Now, who do I pick to be the f and the g? Who do I pick to be f?
Natural log.
So it's going to be f big G, take away, don't know why I'm at an angle, but too late now. That guy. So log x times the integral of 1 gets you x, so that's x log x. F dash gets you 1 over x, integral of 1 gets you x. So it's x log x, take away the integral of 1, x log x, take away x. So, I mean, it's like 3-4 lines, maybe a minute. It's not that long. Okay, last piece of the puzzle. Don't we now need to use this to find C? Great. So, when x is 0, y is 6.
When x is 1.
Yeah. Why did I say 0? Oh, I know why I said 0, because the log is 1 is 0. This is a general solution to our differential equation. We're now going to get the particular solution. So this is 6. 1 over 1 squared is 1. 1 times the log of 1. Take away 1. Add C. I need a couple of extra lines here. We have got 6. The log of 1 is 0, so that goes away. And that's just 1, so I don't need to worry about it. So it ends up being that, which makes C7. So y will be 1 over x squared, x log x, take away x, add 7. And I guess I could multiply that through. I don't think I'm going to bother this time. I think that looks quite pretty. Are we good? Then we are now moving on to our final question. Okay, this guy needs a bit of fixing. It's not really in the format that needs to be. First thing I'm just going to do is to get this guy over here. Why did I get the 3u over here and not the t squared over here? Because this is the right thing to do in the other window.
Because du is our y, so we need to have out the u. Yeah, y stuff.
Yeah, no, makes sense. You got that? I mean, it's a little mistake, but I guess it could happen. Now, in this case here, have we seen enough of these to know that the next problem is getting rid of this t, so the derivative's on its own. So I'm just going to take care of that by a dividing process. I got this guy and I got this guy. And I don't know why I'm kind of squinky, but P of t is this guy, Q of t is just that guy. And that would be step 1. We now find the integral of e to the pt, that fella. That's going to be the integral of negative 3 over t dt, which is going to be 3 natural log of t's. Okay, where's that going to go? What am I going to do about negative 3 log t? It's going to be changed into something.
Would it be ln of t to negative third?
Correct. And won't these two cancel out and you'll be left with that guy? So that's basically step 2 done. So now we're going to find the solution. In this case, it's u, 1 over t, the integral of I t q t, one over this guy, the integral of this guy times q, okay, let's try and make things pretty. 1 over t to the negative 3 is probably not the best way to write that. What's it equivalent to?
T cubed.
I know we don't get a lot of practice, but once you see it 2 or 3 times, isn't there a commonality? Similar things tend to come up. You know, like e to the log seems to come up a lot, right? And 1 over t to the negative 2 or e to the negative t squared, that kind of thing seems to appear quite a bit. Now, when you put these two together, you get that. So I'm looking at adding 1 to the power and dividing by the new power, add C. I think in this question, distributing the t cubed probably would be a good idea. Agree? Because that looks pretty clunky, doesn't it? Kind of messy. So t cubed times this guy gets you negative t squared, and t cubed times this guy gets you c t cubed. Everything good? Now we have a boundary condition which says what? U to the 5 is 100. So when t is 5, u is 100. So we put 100 in here, take away 5 squared, plus c times 5 cubed. So that's 100 equals negative 25 plus 125 c. If you add 25 to both sides, oh, c ends up being 1. And so our particular solution is negative t squared plus 1 lot of t cubed. And there's our particular solution to this differential equation.